Question number 1. Determine whether each graph represents a polynomial function or not. Explain reasoning. So here, a polynomial function, you can look back at your packet on page 404. 404 tells you all the properties of a polynomial. So on page 404, it's helping you. For example, in this one, although it tells you the answer, let me explain it. This graph represents a polynomial function because it is continuous. The word continuous just means kind of like your autograph. Notice how I didn't pick up my pen there. It's increasing, so it has this idea, increasing to infinity as x approaches infinity and decreases as x approaches negative infinity. Essentially, that's end behavior. That's our sentence. As x approaches either positive or negative infinity, f of x approaches positive or negative infinity. It has to go either up or down, right? So they've just given you a graph. This one doesn't necessarily need to be smooth because it is a linear. Turn the page. Question number 7. Determine whether each set is closed under the indicated operation, then write an example to support your answer. So if it's closed, it's on the, we use that example of food, right? It's on the menu. Can you imagine if you go to a seafood place, right? Maybe Red Lobster, I really enjoy Red Lobster, and then you go to, you ask me, hey, can I order spaghetti? And you're like, this is a seafood place, not an Italian restaurant, right? We don't serve spaghetti here. You might think like different types of pasta, yes, but maybe I want like specifically red sauce. And you're like, that's the wrong menu. So to help you answer these questions, here's the clue. It says, is the set even integers closed under subtraction? So you're like, Mr. Ing, I'm not sure what even integers are. So you look back at your packet. And on page 406, it actually tells you if you forget what an integer is. An integer is all of the positive and negative numbers, including 0. But they specifically want evens. So for example, -4, -2, 2, 4, and 6. And then with these numbers, can I use subtraction? So it has an example. 6 minus 10 is -4. Class is -4 on this list.
Yeah.
Yes. So that means it's closed. I can do another example. Let's do 6 minus, because they want subtraction, -4. Class, what does that equal? Class is 10 on our list. Yeah, so it is closed, right? And what you're trying to do is to test if it's closed or not, you're trying to think of the counter example that makes it wrong. To make it wrong, right? So that's how you do question number 7. Look back at your list to help you look at your definitions of your real number system, and then write out those numbers that might help you, and then look at the math operation. Question number 13. Add, subtract, multiply, or divide each set of polynomials to show whether they are closed under the indicated operation. Use a graph calculator to sketch the graph of the resulting polynomial to verify your answer. Question number 13 says, are the polynomials y1, I have a quadratic because it's the power of 2, and y2, are they closed under addition? So essentially what you're doing is you're taking y1 value and you're adding that to your y2 value. And then you're substituting with parentheses, right? And here they're showing you just a vertical stack. We've done in class a horizontal. And then you just line them up with like terms, and you realize you get 2x squared minus 5x, and those cancel. So you're left with 2x squared minus 5x, and it is closed under addition because your answer is a polynomial. This is a polynomial. And then you're going to take your answer and you can graph it, and you can see that it has n behavior. It's smooth and continuous. And algebraically, so this is the algebra part, it's written and it has variables as letters, and its exponents are numbers. Okay? So that's how you do the rest of those questions, and I think you can do the rest of the packet.